I am Dr. Kalaiarasi from School of Computer Science, Tamil Nadu Open University. I am the program coordinator for BCA and MCA programs. I would like to discuss about the computer fundamentals. The subject code is MCA 01. We are going to discuss about basics of computer and computer organization. The word computer comes from the Latin word compute, which means to calculate. So thereby a computer is an electronic device that can perform arithmetic operations at a high speed. A computer is also a data processor because it can store, process and retrieve data whenever desired. The activity of processing data using a computer is called data processing. So data processing combines the following steps. So first data is captured, then it will manipulate in the CPU, then the output will come, we can see it as in our monitors, that is the output device. So the processed data is called it as information. Data is a raw material used as input, and information is the processed data obtained as output of data processing. So the computers has the following specific characteristics. It is automatic, speed, accuracy. So first we will discuss about the automatic. When we gives a job, computer can work on it automatically without human interventions. So the speed is also compared to human. Its speed is also very quickly it will calculate. So computer can perform data processing jobs very fast, usually measured in microseconds, nanoseconds, and picoseconds. So accuracy of a computer is consistently high, and the degree of its accuracy depends upon its design. Computer errors caused due to incorrect input data or unreliable programs are often referred to as garbage in, garbage out. That is GIGO. Next, vigilance. Computer is free from monotony, tiredness, and a lack of concentration. It can continuously work for hours without creating any error and without crumbling. Next is versatility. Computer is capable of performing almost any task if the task can be reduced to a finite series of logical steps. Next, power of remembering. Computer can store and recall any amount of information because of its secondary storage capacity. It forgets or loses certain information only when it is asked to do so. So the generation of computers, so many computers has invented from the 19th decade itself. So the Mark 1 computer is discovered in between 1937 to 44. So Atana soft very computer discovered in 1939 to 49. Then ENIAC 1943 to 46, the EDVAC 1946 to 52, the EDSAC the 1947 to 49, Manchester Mark 1 1948, the UNIVAC 1 1951. Next we are going to discuss about the basic computer organization. First we will discuss about the how the input is to inputting the data, then storing the data, then processing. First, inputting, the process of entering data and instruction into the computer system is called it as inputting. Next is storing, saving data and instructions to make them readily available for initial or additional processing whenever required. Next one is processing, performing arithmetic operations, that is addition, subtraction, multiplication, division. These are all called arithmetic operations, and logical operations like equal to, less than, greater than, that is comparison is called it as logical operations on data to convert them into a useful information. Next one is outputting, the process of producing useful information of results for the user, such as printed report or visual display. Next one is controlling, directing the manner and the sequence in which all of the above operations are performed. So the figure shows the central processing unit. Here how we are inputting the data, then, what CPU is performing, then how we are going to get the results uh, is explained in this figure. So first program and date. So we are inputting the data. Then storage unit is called secondary storage is there, primary storage is there, then control unit and arithmetic or logic unit. The concern storage and control concern unit will do their task when we inputting the data. So the output will be going through the secondary storage and as well as from the control unit. So the processed information, as already discussed in the previous slide, the information is the processed data, that is called it as a result. We will see the output through our monitor. An input unit of a computer system performs the following instruction. First, it accepts or reads the instruction and data from outside the world. So, while inputting the data from we are the only person going to input the data. So that accept the instruction and data from the outside world. Then it converts this instruction and data in computer acceptable form. It supplies the converted instruction and data to the computer system for further processing. An output unit of a computer system performs the following instructions. It accepts the results produced by the computer, which are in coded form and hence cannot be easily understood by us. So it converts these coded results to human acceptable form, that is readable form. So machine language, machine can understand that is computer can understand only zeros and ones, only digital bits only it will accept. But as a output we are going to see as a human readable form. It converts the coded results to a human readable form. It supplies the converted results to outside world. The storage unit of a computer system holds the following: data and instruction required for processing received from the input device. So intermediate results of processing, final results of processing before they are released to an output device. Next one is next we are going to discuss about the primary storage. The primary storage is has used used for the following purposes. It is used to hold running program instructions, used to hold data, intermediate results, and a result of ongoing processing of jobs. The primary storage is fast in operation. It is the capacity is very small and expensive. It is a volatile memory. The primary storage is a volatile memory. Since the when we switch off the computer or when the power is goes off, the complete data will be erased. Next one is secondary storage. So for that we are going to use the secondary storage to store the data permanently in our for our purpose. So it is used to store program instructions. Secondary storage is also used to hold data and information of stored jobs. So it is slower than the secondary memory, but it has a large capacity, then cheaper than the primary storage. So retains the data even without power. So that is the advantage of secondary storage. Next one is arithmetic and logic unit. The arithmetic and logic unit of a computer system is the place where the actual execution of instruction takes place during the processing operation. Next one is the control unit. The control unit of the system, computer system, manages and coordinates the operations of all other components of the computer system. This is the arithmetic and logical unit. We will combine together is placed in the central processing unit. It is the CPU is the brain of the computer system. It is responsible for controlling the operations of all other units of a computer system. A system has the following three characteristics. Any system has the common following three characteristics. It has a system has more than one element. That is the first one. Second one, all elements of a system are logically related. Then third one is all elements of a system are controlled in a manner to achieve a system goal. A computer system is a system as it comprises of integrated components, that is input unit, output unit, storage unit and CPU, that work together to perform the steps called for in the executing program. So these are all the parts of the computer inside the system. So arithmetic logic unit, auxiliary storage, central processing unit, computer system, control unit, controlling, input interface, input unit, inputting, main memory, then output interface, output unit, outputting, primary storage, processing, secondary storage, storage unit, storing system. In computer, there are two types of number systems being used. First one is non-positional number system. Next one is positional number system. So the characteristic is use symbols such as 1 for 1. That is Roman numerals will be used for the number system. 3 for 3. So as shown in the slide. Each symbol represents the same value regardless of its position in the number. The symbols are simply added to find out the value of a particular number. So difficulty facing the system is it is difficult to perform arithmetic with such a number system. Such characteristic is use only a few symbols called digits. These symbols represent different values depending on the position they occupy in the number. The value of each digit is determined by the digit itself, the position of the digit in the number, then base of the number system. So base is the total number of digits in the number system. The maximum value of single digit is always equal to 1 less than the value of the base. So a positional number system. First we are going to discuss about the positional number system. In positional number system has 10 symbols or digits from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hence its base is 10. Total digits is 10, but it starts with 0 and ends with 9. The maximum value of a single digit is 9, 1 less than the value of the base. Each position of a digit represents a specific power of the base. That is base 10. We use this number system in our day-to-day life. For example, 2586 is the number, so base 10 with the base 10. So we can represent this number into as we have discussed in the previous slide. First, it starts with the 10 to the power base 0, 10 to the base power 1, 10 to the base power 2, 10 to the base power 3. So each digit, first we should take 6 is the least significant digit. That into 10 to the power 0. Then each one we have to add. Then next digit is 10th position, that is 8 into 10 to the power 1. Then plus 5 into 10 to the power 2 plus 2 into 10 to the power 3. So the actual result is 10 to the power 0 is 1. So 6 into 1 is 1. So here 10 to the power 1 is 10. So 8 into 10, 80. 10 square, that is 100. 5 into 100 is equal to 500. Then 10 cube is 1000. 2 into 1000 is 2000. So finally all together we add, we will get the final result. So next one is base 2, that is octal system, that is positional number system. So this is this base is represented as 2. So here only two symbols or digits will be used, that is 0 and 1. Hence its base is only 2. The maximum value of a single digit is 1, that is 1 less than the value of the base. Each position of a digit represents a specific power of the base. The number system is used in computers. Here the value should be less than the 2, that is 1 and 0 will be used. Here 10101 base 2 is the value given for adding purpose. Here we have to represent 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 2 to the power 3, 2 to the power 4, 2 to the power 5. Same like we have to multiply each digit, each position of the number with the base 2. Then we have to add. So all together finally we get 21 to the base 10. That is this is a conversion of digital system. In order to be specific about the number system, we are referring to it as a common practice to indicate the base as a subscript. Thus we write 1 base 2 is equivalent to 21 base 10. Bits stands for a binary digit. A bit is a computer terminology, means either a 0 or 1. A binary number consisting of a n bits is called an n-bit number. Next one is octal number system. That is, this is also positional number system. It has a total of 8 symbols or digits from 0 to 7. Hence, its base is 8. The maximum value of a single digit is 7, 1 less than the value of the base. Here, each position of a digit represents a specific power of the base 8. Since there are only 8 digits, 3 bits, 2 cube is equal to 8. So, are sufficient to represent any octal number to binary. So, to the base power 10 is called it as binary. Any number base represented with the base 8 is called it as octal. So, here we are converting the octal number to binary. So, how this can be solved using this number we will discuss now. 2057 base 8. Here also the same as discussed already in the previous number system, but here the base should be 8 to the base 0, 8 to the base 1, 8 to the base 2, 8 to the base 3. The same procedure will be followed here also, but here the base will be used it as 8. So finally we will get from octal to the binary, we will get 1071 base 10. Next one is hexadecimal. That is, it has 16 symbols or digits from 0 to 15. That is always, hence base is 16. Here the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So after 9, instead of 10, A, instead of 11, B, instead of 12, C, instead of 13, D, instead of 14, E, instead of 15, F will be used. So we have to use after 9 only A, B, C, D should be represented. The symbols A, B, C, D, E and represent decimal values like as already discussed. The maximum value of a single digit is 15, 1 less than the value of the base. Each position of a digit represents a specific power of the base 16. Since there are only 16 digits, that is 4 bits, that is 2 to the power 4 is equal to 16 or sufficient to represent any hexadecimal number in binary. So hexadecimal number we have to represent it as here this example is going to represent about the conversion of octal to binary. Here we are going to discuss about the here we are going to calculate using the base 10. So 16 to the power base 0, here 16 to the power base 1, 16 to the power base 2. Instead of here A is represented 10, F is represented 15. So hence the 16 power 0 is 1. Instead of F we have to replace 15. Instead of A we have to replace 10. Then another value is 1. So we have to multiply the base value. Then we have to add. The final result will be 431 base 10. So determine the column positional value of each digit. This method multiply the obtained column values by the digits in the corresponding column. Calculate the sum of these products. Here the example is conversion of octal to binary. Here the values, these are already discussed as the previous slides. The common values multiplied by the corresponding digits. Here these are all called sum of the products. Division remainder method. Divide the decimal number to be converted by the value of the new base. So record the remainder from the step 1 as the right most digit, least significant digit of the new base number. Divide the quotient of the previous divide by the new base. So record the remainder from step 3 as the next digit to the left of the new base. So repeat steps 3 and 4 recording remainders from right to left until the quotient becomes 0 in step 3. Now that the last remainder thus obtained will be the most significant digit, that is MSD of the new base number. For example, 952 base 10 we have to convert it into octal, binary to octal. Here the solution is we have to divide. Here 952 should be divided by 8. The remainder here the remainder is 119. We are getting remainder is 0. So the again 119 will be divided by 8. We will get 14. Remainder 7. Again 14 will be divided into 8. We will get 1. The remainder is 6. Then the less than 8 means the 0 we have to put 0. Here the 1 will come. So the value of value will be reversed, that is 1670. That from the bottom to top we have to take the answer it as from the top to bottom to top, that is 1670 base 8. Then convert the original number to a decimal number base 10. That is decimal number. Base 10 means decimal. Convert the decimal number so obtain to a new base number. Here we have to discuss 545 base 6. So this we have to convert the base 6 to base 10. Mandatorily we are going to use only base 2, base 10, base 8, base 16. So instead of these numbers, alternate number has come. It should be converted to base 10. So that's value is 209 base 10. Here 209 base 10 to base 4. So here we are dividing these numbers, then get the value as already discussed in the previous slide. We have to take the answers. We have to take the answer from the remainders from bottom to top. So 3101 base 4. So 545 base 6 is equivalent to 2 to the 209 base 10. That is equivalent to 3101 base 4. Here the step 1 for dividing the digits is divide the digits into groups for 3 starting from the right. Convert each group of these binary digits to one octal number using the method for binary decimal conversion.